So I record this to the cloud. Okay. Now, questions were where? Okay. You don't mind if your voice is on this, do you? Okay. You guys all heard that. Then don't talk.
So for number 2, I have I did A, but I'm pretty sure I did it wrong.
Why do you think you did it wrong?
So I have a given of 25.0 meters.
Mm-hmm.
And then I also had a given of the initial velocity of 0.0 meters per second.
Mm-hmm.
Okay. And then it says, how fast is the flower pot moving when it strikes the ground? Which it would be, I'm looking for final velocity.
Mm-hmm.
So I have the equation I started with is
Slow down, slow down.
displacement equals 1/2.
Wait, slow down, slow down. Okay. So you're going to have the height of the 25.0 meters. You have an acceleration. It's going to be negative 9.81 meters per second squared. And you're looking for VF. And you know that V initial was. And then what did you have?
I feel like the thing that I missed was I didn't have the acceleration because I didn't realize that it's going to be the same. I thought it was different. So I probably have the wrong equation written down.
Well, what did you use?
I use the displacement equals 1/2 multiplied by VI plus VF and parentheses multiplied by time. But we don't have time, so we're trying to find time.
Okay, so you are trying to find time, so this will be helpful for part B, right? And for part B,
I was reading.
so for part B, you first need to do part A, which is where you want to find VF. So if you find VF, this will work for part B.
For part B, I did time equals velocity final, velocity initial over acceleration.
That's what I did here. And that's kind of what you have here, so. Okay, so what are we going to do for A?
I'm going to use the equation final velocity squared equals initial velocity squared plus 2 multiplied by acceleration multiplied by displacement.
Okay, right.
So I'm going to
And then to make it simple, I just took the square root of both sides. I didn't have to rearrange anything to find final velocity. Yes.
take the square root of both sides.
You take the square root of both sides. So the VF squared just becomes VF. And then you need the square root of that whole side. And you don't even have to rearrange that because you're looking for VF. So that should work, right? And I think the example gave you the delta T. Yeah, it did. The example last equation gave you finding the time.
If the acceleration is negative, your final velocity is going to be negative. Right.
And here, because you're moving up and down, the negative just means which direction are you going. So if it's going down, it's negative. An acceleration of gravity is always down. So it's always going to be negative 9.81 meters per second squared. Is that a little bit better? How did the rest of you do?
For 2A, we get 22.1.
Yeah,
Negative 22.1.
For A, no. Take the square root.
Because I got.
Oh, I'm sorry, I'm looking at number 1. Yeah, you're right. I was looking at number 1. I'm going, no, I was looking at number 1. Yeah, number 2 is 22.1. The most common mistake you're going to make on these is to forget to take the square root. It's always my issue. Yes. And here,
I'm gonna do
again,
B now.
all the negative and positives are, is it going up or is it going down? Let's see. All right, B.
I'm going to figure that I have everything except for time.
Mhm.
So I'm going to VF equals VI plus acceleration time. Okay.
Yeah, rearranged. Hi, yes, break is over. Okay, okay. Oh, you stopped for a drink.
And so when I rearrange it, I would, because I'm trying to find time, I would subtract A and divide by initial velocity.
Mm-mm. Are you looking at, are you looking at step 2 on page 63 in the example, where you have this? Where you have this?
Yeah, that's what I was going to use, and then I had to rearrange it.
Right. Okay, yeah. So rearrange it.
So would it be minus A divided by VI? No, it would be minus VI divided by A.
By, yes.
Okay.
So you're going to have this. Okay. And you're going to divide both sides by A. And you have the VI, VF minus VI over A equals delta T. Is that what you use, Mason? No, that's not where you went. Okay, so what you want to do, whenever you have something that's added together, you want to subtract everything that doesn't have your unknown variable in it from that side. Yeah, yeah. I'm sorry, what? You want to take a look at 3?
Yeah, I didn't have anything on 3. I was very confused.
Okay, well, let's deal with let's deal with some variables first. You shouldn't have a negative.
Negative 22.1 meters per second minus 0.0 meters per second divided by negative 9.81 meters per second, and I got 2.3 seconds.
I'm not even sure you got those numbers.
Me? Oh, I want to be.
And you're looking for final velocity, yes? And we know a time, but be careful with the time, because the time is round trip. Yeah.
Where's the time?
Oh, maybe I calculated that.
Like, I don't know the time at all.
Yeah, that's what we calculated at the end. So let's get that out of here. I should look at the book instead of what I read.
Would it be positive 9.81 since it's vertically upward?
No, because the acceleration, gravity is always pulling down.
Oh.
It doesn't matter. It doesn't matter where this is. Gravity is going to accelerate in a downward direction. So gravity is always negative. So that's easy. And that is what makes the the up and down motion easier because we always know the acceleration if you're on Earth. Okay, so let's take a look at this, at what happened here then. We had an object and it was going to go up and then it was going to come back down. Okay, so what happens with this guy is you have a starting velocity of 8.0 meters per second. That's the velocity that the person's hand gives this as it's throwing it up. As soon as that object leaves that person's hand, there's no more acceleration from their hand acting on it. What's the only acceleration acting on it? So yeah, I did this picture thinking it would better. So it's going to take it some time to go up. Okay, and it's going to take it some time to go down. If the only acceleration acting on this is 9.81 meters per second down or negative, okay, is the distance up and down going to be the same? Yeah, it's because it says back to its starting point. So the distance is the same, the time is the same. Well, we don't have a distance, do we? No. Well, all we have is these two variables. We have our initial velocity and we know acceleration. Okay? We do know that the first time interval has to equal the second time interval because the only acceleration acting on it is acceleration due to gravity, which is equal both times. So the acceleration, gravitational acceleration, is going to act on it while it's moving up. What's going to happen to the motion when it gets to the top? And stop. So at the top, the velocity at the top is going to equal 0. Okay, because it stops. So you've got two things happening here. You've got an up and you've got a down. And so we know this. And we know that A is negative 9.81 meters per second squared. So by inspection, if you have, what's the average acceleration equation?
Acceleration?
Mhm. Yeah. Okay. And we know that we have 8 meters per second is our initial velocity. So if the time doesn't change between the up and the down, the time doesn't change and the distance doesn't change, what's going to be true of the velocity? Right. So if it starts out at negative 8.0 meters per second, if it starts out as positive, because it's going up, and what would it be? Yeah. Because the acceleration is the time is equal and the time is equal, so the velocities will be equal. They'll just be in different directions.
So is that the answer, or would it be 0?
Yeah, the final velocity would be 0, though, wouldn't it? Because it's hitting the ground.
I think it's implying here right before when it returns to the starting point.
So to wherever it was released.
Yes, it
Let's
is.
say it's 2 feet above the ground. At that 2 feet level, it's
At the exact space where it's released is where it's telling you that it ends up.
They need to be more clear, because I thought maybe the hand was still like they're lifting it and then.
Sometimes you need to be careful when you read these because you could read them either way, some of them.
So the final velocity would be -8 meters per second.
Yep.
Okay.
Okay, we feel a little bit better about 3. Okay, how are we feeling? What?
I'm sorry, we won't.
Is there anywhere else you need to go during class today?
No, I.
Okay, go. Good, go. Okay. 4, we can 4.
I still have to do 3D.
Okay.
I just have to do a formula there.
You do, and remember you have time in 2 directions. You have up and you have down. So your equation, your calculation is probably going to give you one of them, but the time is going to be equal both ways.
So you just multiply by 2.
Yes.
And then for 4, I messed up my equation, but looking back on what I did on number 2, I know what I messed up.
Okay.
So I'm just gonna
Okay.
do that.
Wait, so for time, you do final velocity minus initial velocity of acceleration.
Mm-hmm.
Okay, never mind.
And that's going to give you
And then
one.
you multiply them.
Yes, because it's going to give you either the up or the down, and you need both ways. So the time is going to be the final velocity minus the initial velocity divided by acceleration. Yeah, and that's going to give you one of the times, either up or down, but both times are equal, so you can multiply by 2. Okay. So you're going to have VF minus VI over A is going to give you the time. And that's the time for one trip, but it asked you for the round trip.
For displacement? Yeah, that was
I like this problem because once you work your way through it, it helps you understand what that acceleration is really doing.
You like number 3?
Once you understand it, I can see how it confused you, but now that you've worked through it, didn't it give you kind of some insight?
Yeah.
Really?
Yeah.
Okay.
I am insightful because the ball goes up and down and it's all the same.
Okay, good. Yay.
Now I actually have to do the. I understand.
Do you need a minute to work through that stuff? You good, Grady?
Yeah, you've been pretty quiet.
Yeah.
I'm just not trying to take it in.
Okay.
There were some that I didn't. And, I didn't understand 3, but how we went through it really. It did. And I'm also changing, because my exit ticket was messed up because I had done the bottom. Like I went down instead of going up, so I'm just copying and pasting everything onto the one that you made. I already did.
-42 meters per second and then 11 seconds.
For which one?
For 1.
Oh, okay, that sounds about right.
For 1? No, we're not there. I thought you asked what was 1.
I did get 1 right though, so that's. No, 3.
For 3.
B.
B, I'm working on it.
Did you get something yet? Let me see. When you're working with up and downs and acceleration, just remember that all that negative sign is telling you is a direction, and you can take it in as, so you can say velocity is 8.0 meters per second up. You can say it's positive 8.0 meters per second. You can say it's negative 8.0 meters per second. You can say it's 8.0 meters per second down. Oh,
We
good.
got 3.2 seconds.
No.
Not what I got.
No.
I got 1.63.
wait, I thought you multiplied by 2.
Yeah, you multiply by 2.
I did.
Wait, you divide it by 2. The number that you get is multiplied by 2 because it's round trip. You divide it by 2 to get half the trip.
I got 1.63 to begin with, and then I thought we had to multiply by 2. so-
Because it's
So,
asking.
okay, wait, I'm sorry. I'm reading what I have written here backwards. Okay, so when you find one of them, you get 0.81, right?
No, I got 1.6.
Yeah.
Because I have,
-8 minus 8 divided by.
You're only doing half of the trip, so it's a 0. yeah.
Oh,
Yeah,
So if we just did that, we.
either final or initial is 0. One of them is 8 and one of them is 0, depending on whether you're calculating the upside or the downside.
But if we did it like that, could we just keep it like that? Because we got one.
Like that.
Like, -8 minus 8 divided by the -9.
But then didn't you get 3 something?
No, I
No,
got
I got
1.6.
Oh, yeah.
Yeah.
I personally think it's more correct to figure out one side at a time. But that works, and it works because it's going the same distance up and down. If it weren't the same distance up and down, that would not work.
okay, I did it.
Yay. How are we feeling about 4?
I did it right. I messed up my equation, but I fixed it.
4? Any takers on 4? Okay.
Now that I've been saying this,
So Mason, you think you can do 4? So you're gonna work on 4? How are you with 4?
I'm good.
Will, you think you can do 4? Grady, how are you with 4? Hyatt, how are you with 4? Oh, wait. Okay, so 4, we know a displacement when we're going back to sample problem F. And in sample problem F, we don't know the displacement. That's what we're looking for. We are giving it a final velocity of 1.1 meters per second up. Our initial velocity here then from the first problem was 6.0. And our acceleration is what? Yep. Okay. And so to find the final velocity, is that what we need? No, we need delta y. So I use this one. I've changed the displacement from delta x to delta y to show that it's going up and down. I've always felt happier doing that because then I can keep them straight in my head, and your book likes that too. So we're good. So now we need to rearrange this to find delta y. So here is where we're going to subtract the initial velocity from both sides. We have 2a delta y. And then we want delta y by itself, so we're going to divide both sides by 2a. And there's your equation. Why? No, I have it on Zoom, so I can record this. Just,
What was her name?
no, because I'm logged in.
It does have an O that's called though.
I'm logged
I didn't
in.
realize that. I was like, because when I'm talking, sometimes it'll show up. It'll show that I'm
That
not
if you have joined the Zoom meeting, well,
talking.
yes.
Okay, yeah. I was like, they know your voice.
But I have nobody on Zoom except me, so I can record this. So. Okay, so then we plug some numbers in here, and we have the 1.1 meters per second, and we're going to subtract, oh, that's going to be squared. I'm going to subtract VF or VI. Yep. And then we're going to put it into times negative 0.81 meters per second squared. And when you're all done with that, Should get something in the neighborhood of 1.77.
I did it.
Better?
Yeah.
Okay, good. Good, good, good. All right, there's one other thing I wanted to show you. And so in your notes somewhere, you might want to make a little table of this. Okay. Oh, there it is. Look, I already had it. You're gonna want to make this little table.
Okay. It'd be like that sometimes.
It's like when you talk on the phone.
I'll be holding my flashlight and like, oh my gosh, I can't find my phone. It's dark.
Yeah,
What
yeah.
is when you're looking for your glasses and they're on your face? I've had that one happen.
Or on your, looking for your phone and you're talking on it?
I've had that happen.
Done that.
I'm like, where did I put my phone?
I'll literally be on like FaceTime with someone and be like, I can't find my phone and I have to go somewhere and they're just kind of like, wait a second. Yeah, they're just
Yeah.
like, I could be in work in like 5 minutes and I can't find my phone.
That's the whole advantage of having an Apple Watch, is the where is my phone?
I don't have an
You
Apple
can ping your phone and it will.
And it's like really loud.
Carter, when we went to
See?
Florida. Oh, that's.
I know.
Yeah, when I lose my phone all the
Florida,
time.
he left his phone in the stand for 3 separate times.
Okay, so you are jotting this down because we're going to do a few calculations with this little table.
It's gonna be one calculation?
A few
I
calculations.
think it's food calculation.
So no, a few. So you've been given an initial, watch, this is kind of like the problem you just did, an initial velocity of 25.0 meters per second. So that's the upward velocity that you're getting when this thing is thrown. There's your table for 5 seconds. I want to see the position and the velocity at each of those intervals go. If you're a geek, you've made a spreadsheet already, but you're not, so calculate it. If you were 2 geeks, you would have made spreadsheets already.
We used to do that freshman year in engineering. Remember how many of those we made with all the calculations? It's so much easier once you learn how to.
Excel spreadsheet has a lot more versatility.
Yeah, see, I also use Microsoft until I got here. And so I really dislike Google Docs and stuff. Like actually, I like the auto save feature of Google Docs. That's kind of nice, but
There's growing for purposes I use for here, but I could never have written my dissertation with people.
I just speak Google because they know everything about us.
it's like every company.
And so does Apple and Facebook.
I just think that.
Yeah, I mean, I'm not that.
What are they gonna know? That I
I'm
looked
not
up the
that
dance
important.
to like a Spanish song 3 times in 1 hour? Use that
What are
information.
you doing in your free time, Lily?
I like dancing.
Somebody is that bored that they make a check out bored.
Go ahead.
It'll probably be at home.
It's just big government control.
She goes from school to home to school to home to
To work.
school to home up to the island.
I
back
say
home.
occasionally.
Pressure sore.
That's the TI.
I just see it clear.
T initial.
Would
It
we
just
add,
says T.
would we add the zero?
That depends.
Right around Spokane.
When it reaches its height, its peak height, it will be 0, but you don't know where that is yet. I think I gave you a little hint here.
See the hint? I don't know what to do with the hint.
You're
No, I know, I
looking-
know. No, I don't know what the.
Well, you know the initial velocity,
I know acceleration.
okay? You know acceleration and you know the times.
Yeah.
So you're looking for VF,
Oh,
and then you
is that
can,
gonna go in V? No, that would,
Yeah.
yes.
okay,
I just didn't know what V stood for, if it was VI, VF.
I'm going straight for
it's the velocity at this time, so
Oh.
this would be the velocity at 1 second, velocity at 2 seconds. And then at 1 second, here's its position, and here is its velocity.
Now I feel this.
Wait, so you want to calculate all these?
Yeah.
They slingshotted it in.
Right now, yes, I'm going to calculate it right now.
Just so I'm not doing all wrong, the first one.
I got 15.2.
Okay.
The first one, what?
Just a second.
For velocity, yes. And is it positive or negative?
Negative. Positive.
It's went up, right?
Yes.
No. You do.
At one, maybe it wouldn't be like 1 second, but at one point, wouldn't the acceleration be 0? Because it's stopping?
At one point it will be, it may not be any of these times though. It may be between one of those times. But yes, it will be. It will turn around for you.
So then for our displacement, we just use our displacement equation.
Let me close the door so these children don't see your mask off your nose.
Oh, I'm getting.
Mask off.
I moved over here so I could have like a mask.
Mask off.
We're allowed to take our mask off. We're allowed to take it off to get a breath. You know, we're like a good distance away from people.
Just remember that you do not have access to facilities at Walter Reed.
Who's that?
Point that out.
If you do, I'd be impressed.
Yeah.
Here's the deal. I'm 17. Fine. I already have.
If you spread it to me, it won't be.
Basically, I would never do such a
You could
Do
right
you
now.
have a choice?
thing. Yeah, because if I had it, I wouldn't come to school.
You didn't want to spread it, you would put
I
your
would
mask
go
up over it.
party.
I have never been tested, and I don't think I ever want to be tested.
I've been tested, it's not fun.
Oh, yeah.
Yeah, I had to prick my own fingers.
Wait, they can tell through your blood?
Yeah. I was in about
The
that.
antibody test, the PCR test for the disease also.
After this, I gotta find the displacement. I'm gonna use my fancy little thing here.
So I had an appointment to donate blood yesterday at 5 o'clock in the morning. And so at 4:25, I was about to walk out of the house. And I called and said, we have to cancel your appointment because you found out the labels for the back of the blood pouch thing. Like, really, Red Cross, really?
Did you go punch him in the face?
No, I was like, really? Then I hear the news that they are starving for blood daily because they've had so many accidents and all the COVID cases. Yet they couldn't take mine because they didn't have a label.
What's it like to donate blood?
You lay them in, then they stick them in their finger, and then they stick them in the arm, and when you're done, you get these.
So what is there not to love?
It's not that bad. It's just that, like, the pulling out kind of feels weird. Like,
Riley, have you started on the
Some
displacement?
people are body sticking
Okay.
right there.
Tell me what you get for the first one.
Okay.
what formula you guys using?
Oh, it's in centimeters. No, it's in meters.
It's
I
in
just
meters.
wrote
Meters, you should be
By
good.
the velocity, you mean final velocity.
Oh my god, I thought it was centimeters.
The velocity,
it.
the final velocity at this
You're
time.
right, centimeters
So
are
this
like
is,
that.
yeah, at this time, you'll have the final velocity this time.
My phone will not stop going off. It's making me annoyed.
We make- My phone never stops.
Briscoe Bay. Sam Gibbons.
You doing okay?
I'm sorry, this is a hardcore battle.
It's like 6 minutes.
I know, what's that to do?
Yeah.
A quiz over what?
This chart, this is part of the things you might be expected to do. So there's this, which we're probably not gonna get to today.
I'm trying.
It all happened because we lost a learning day yesterday.
We did.
I was
A
so
very
happy.
valuable learning day. How dare they?
I was gonna get so much done and get so ahead yesterday, and I worked all day and
I
didn't get
messed
there.
up.
I woke me up and said, we're late. I was like, let's go. He woke me up again and he said, we're canceled. And I was like,
Grady
oh my
lives
God,
at my house.
even better. Sometimes.
Is he living in your basement?
Yeah, we just.
I sleep on
Messed up.
I woke up and Kale was sleeping in my bed. So I went upstairs to get clothes and I was like, because he doesn't have a room.
Well,
He does.
he does now.
There's no furniture in there.
You know, getting moved to the lake, huh?
So it's already there.
I'm gonna do that. I almost have a house now.
Oh, really?
Are you guys done with this? Do you have this written down?
Yeah.
Yeah, I don't actually have to do it. I keep getting different.
Well, here's where you're starting. Okay, and you know that VI is the
Oh,
20.
kind of.
Plus we got-
Good.
Okay, so you can find time, and then if you have time, you
Okay.
can find how far it went.
Because on my card, I was doing this. I have it.
Are they all the same?
I have it
They'd
as
be
displacement.
different. They'd be different.
Is what?
Nothing, I'm gonna do
The only thing that will be the same is the acceleration.
I'm just
The only thing that will be the same is acceleration.
Okay, I see where they're going. Why are you squaring things?
What are you squaring things?
Wait a minute.
Are you using the
Use the
one?
formula you used for 4.
But we have a formula right there.
There's so many different formulas.
Not bad.
Yeah, the one for Y for the time. Is that, right? Is that the one you're using?
Thank you.
The displacement.
It's been a goal of mine.
Where you square the time.
No, I'm not using
That
it.
is not the one I use.
Are you starting on the displacement?
This one?
I started.
For what?
I have.
Oh, for Y, okay,
Okay.
no, that's not the one used for Y.
And then, do you want us to do this?
So, yeah, and we'll talk about that tomorrow. Make sure you don't have any other questions. Maybe play with a few other practice problems, and we'll do the quiz on, what day is this? Tuesday, Wednesday, and Thursday?
So this is our homework.
Wait,
Yeah, give that a try.
you wouldn't believe what I saw over the weekend.
Someone with a mask over their whole face?
I was getting a hair on.
Okay.
I dropped my buddy off at his dorm and I'm driving and I look to my right at a soccer field and I see like 20 people in full karate outfits, like just doing like air karate. Like, they're like,
Isn't
like,
that called,
I'm gonna watch it at work today.
martial arts.
Okay, I got 25 minutes.
It was
Yeah.
funny.
Okay.
That's what I got.
I just made that up. I don't know. I know
no,
it's.
I'm pretty sure it's called Tai Chi.
Hey,
I know, it's no, it's focusing on your.
There's a bunch of different names for it. All right.
karate.
Jiu-jitsu, you know what I'm talking about?
What?
Maybe.
You heard me.
You're gonna get punched. Guys, I can officially No.
Me either. I can. Okay, you know what? I don't
Okay,
know
what are we
if
doing
that's
in
fine.
anatomy? Did I make copies for you guys? Yes.
Dude,
If you have anything done, please, I will be happy to take that.
Anything done, problems, lab, any of those things?
So my lab I got done, but I wanted to go over the analysis questions with someone else before I turned in.
And so,
Just in
yeah.
case I did.
It's like,
something wrong.
okay,
So why don't you tell me
You
the
read
numbers and go back and do it?
Okay, yeah, I can do that. Build my graph.
I would be happy, I would be happy to look at anything.
Is this looking correct?
Like, where were those teachers? Wow, like, why don't we have those? I
Yeah,
bet.
yeah, you should turn around the journey. Thank you, close.
You want this?
Anything that you want.
Okay, well, I have a lot more, but I forgot my notebook at half.
Your one job, they can bring all this stuff.
Mrs. Lee, my house is in a homework graveyard currently. I forgot I went to the grade, forgot it all.
Like, you know that thing in Rudolph, where it's the island of lost
Oh,
toys?
we're
The
gonna have
island of lost toys.
That never happens to you. It's my job.
I know.
Yeah, we need to revive our homework.
And my job is to remind him to get hit.
Done or here?
No, he has to.
I should get here.
We both have-
I have this folder that I always had my work in for years. I still use it. And I just forget all
I
the
feel
time.
bad. I only carry around like one binder now. I never just borrow.
Oh, hey, you get to leave. Wait, it's over? Well, I'll see you in like 45 minutes.
See you there. Actually,
I'll get it tomorrow, Mrs. Lee.
Way better. Recording. Want to stop.